Welcome to MATHurdays. Math's so fun, we do it on Saturdays. Hi, everyone. My name is Teresa Wells. I'm an assistant professor at George Mason University in the Mathematics Education Leadership Office. I've been teaching online now for a decade and specifically using interactive slides and focusing on the affordances of collaboration, interaction, and student voice for the past 6 years. So I've had a jump start on all this online learning, and I'm here today to share with you some problems and the way that we solve these problems from the lens of an adult learner and also as children learners. Um, I've had experience teaching online for kindergarten all the way up through college level math and hope to share some of those tips with you today. You're going to be working within two platforms. If you can hear me, that means you have Collaborate open, and nice job. And you should also be able to see the slides. Here is the link in the chat box. As a way of demonstrating agency, I do not project my slides on Collaborate. Instead, I ask you all to follow along with them and interact with them. I'm going to continue to spam your chat box with this link as other folks arrive so that they can have access to it as well. On slide one, you'll notice there are a couple clickable buttons, ways to continue learning. There's my email address, my website, my Twitter handle, and my YouTube channel. So feel free to click on those, check those out. And on slide two is some information if anyone is interested in becoming a K-8 mathematics specialist. We do an endorsement master's program at George Mason, and this is the way that we teach. So there's some information there for you. And if you join me on slide three, these are the links you're going to want to bookmark for today. If you like any of the templates from today, they are available for you to use. And if you would like a recording of today's session, other sessions, along with blank slide decks and completed slide decks, they're all available at that link there. All right, let's go ahead and jump right in with successes and celebrations. I have several slides beginning on slide 4, then 5, 6, 7. I'll even add an extra one because it looks like we're getting lots of images now, which is lovely. Find a space and insert a text box and tell us what is it that you're celebrating, what successes are going on in your life. The text box can be found at the top toolbar. It looks like a little T with a box around it. And you can place it anywhere on these slides. I'll ask a couple of you to turn on your microphones and elaborate a little bit on it. And let's start with Erin. I've got a lovely picture of picking strawberries. How was that? Where did you go?
Hi, Dr. Wells. We went to Wegmeyer Farms out by Oatlands Plantation in Leesburg yesterday. It was so lovely, and the strawberries are so sweet.
Oh, I should really do that. We got some strawberries on a delivery service, and they just taste like the color gray. They just don't taste like anything. I need to go get some fresh ones right off the plants. Awesome. Let's see. Chelsea, tell us about the school bus driver experience.
I've been driving a school bus since 2013 as my means to become a teacher. I still plan on doing it every once in a while, even though now I have my own classroom. But the PD they had us do because of COVID, it was over 6 hours to do. It took over a couple of days. But yeah.
Oh, very cool. It's always exciting to see kids in that environment that's not yet in the classroom, but still structured there. So excited to hear about that. Raha, what are you doing with friends and family? What a lovely picture you have.
So my sister's in-laws, one of the older kids just graduated high school, and they had a little graduation party, so we all like masked up, but that was one of the pictures I took without my mask. But it was cool to see like how strong these high schoolers are, like coping with this COVID and still being positive about their next step. It was exciting to see everybody.
Oh, yeah, lovely. And Lily, tell us about your cooking.
Good morning, Teresa. So I've always loved Indian food, but I never learned how to make it. And some of my best friends are Indian. So to honor them and to appreciate diversity and all that, I thought that maybe it's about time if I learned how to cook fish curry. So I tried it yesterday and it turned out really great.
Oh, I love wonderful flavors and spices from around the world also. I can definitely relate to that, and I wish I could have a taste of that right now.
Thanks.
Oh, folks, such lovely ways to connect with one another. I am so excited that I get to read all of your successes and your celebrations. From those of you who this is your first time, we always start like this. Some folks are already making long-lasting connections with other folks who come regularly, and it's exciting to see that here. Um, all right, let's jump right into our math routine. Our bookmark starts on slide 9 and the routine is below. This routine is based off of infographics and oh boy, I'm getting one heck of a thunderstorm. I hope our power doesn't go out. If it does, I'm going to encourage you all to continue as a group, but we'll see how this facilitates today. So there's several slides beginning on slide 10 all the way through slide 18. And your job in this routine is to look at the infographic and interpret it. You've got one little box available for any interpretations that you would like to write. And if somebody else has already clicked that box and started writing, then just go ahead and click another box. But these are interactive. You just double click on a box and you start writing. So what can you interpret from this infographic? Someone says the ratio between reusable items and disposable items is huge. Can you turn on your mic and elaborate a little bit more? How do you see that in the infographic?
Hi, Dr. Wills. It's Erin. I see it as, when I look at, for example, like the one metal straw for 540 plastic straws, that disparity and just that comparison is huge. One per every 540. And same with a lot of these other things. The only one, I guess there's some small ones, but a lot of them are very large.
Indeed. And speaking of very large, I just went ahead and changed the color of your box to yellow. That's one way I can give students a heads up that I'm going to call on you. On slide 14, the bottom right, you use some pretty big numbers here. How do you see these numbers as making a big difference?
Hi, Teresa, it's Lauda. So I just noticed that 167 plastic water bottles was very close to 170 plastic bags. My eyes were just drawn to those numbers because they were fairly equivalent, and I thought like, wow, that's incredible. That's one reusable item is going to take the place of almost 300 disposable plastic items.
Indeed. Wonderful. And then on slide 15, I have highlighted your box in yellow. Tell us a little bit more about what you noticed.
Hi. So yeah, I saw that there are 7 items here that were highlighted. And for the very last item, the cloth towel, it seems like it has the highest reuse value because there is the biggest quantity. So one cloth towel is equivalent to 7,300 paper towels, whereas the other ratios have smaller quantities in, I guess, in comparison.
So I heard April say a really neat term here. April said that paper towels has the highest waste value. What do you guys think about that idea of a waste value? Um, and how might you rephrase this or apply it to a different thing? That term is really interesting. Who else connects with that? So I wonder if we can apply that term waste value to a different one. Can you write a sentence that uses the term waste value in the chat box? How could we use waste value in a sentence? Go ahead and try and type that in the chat box. And Gabby, you mentioned waste value as related to unit rate. Now that's another term. Could you tell us a little bit about what you're thinking with unit rate and how you might see a relationship or a relationship developing between the two?
Yeah, I just know that unit rate is like the amount per one item. So I was kind of thinking like whatever the waste value is, it's in relation to the one item that you're using and how many you're saving.
Indeed. And then, so we've got this relationship to one, which is really important because if we said that, 2 reusable cups is equivalent to 500 coffee cups, well, that ratio is a little bit weird in comparing all the others to one. I also noticed that Sheila says the waste value of paper towels is extremely high. So now we're using words like high, comparison words, with this new term of waste value. And we might even use that term with ratio also. But with our teacher hat on real quick, I want us to think about the fraction of 1 over 7,300 and what we would want students to think in terms of fraction. And then also how we might have them think of it in terms of high waste value. Does anyone see anything kind of funny there with the idea of the fraction versus high waste value? Yeah, Erin, tell us what you mean by the fraction is low.
So when I'm looking at some of the waste values, so for example, the cloth towel to the paper towels, it's 1 over 7,300. So if I'm looking at that in decimal form or even in fraction form, that's a very, very, very small number. So when you want to say waste value, I think marketability. And I'm going down that path, but I'm thinking like when you think waste value, you want it to be a high waste value to kind of have that effect. But in a way, we're kind of creating this low waste value. So it's almost like this inverse relationship.
Indeed. And Chelsea even gives us a decimal, 0.0073. And Nan says the smaller the fraction, the higher the waste value. And so those are some generalizations that when kids are able to make that, I know they're able to see the context beyond the mathematics, that they're not trying to just find random common denominators or apply some kind of an algorithm with it. Instead, they're making context relate to the mathematics. All right, folks, that's just a little routine to get us warmed up. I am going to ask you to head on down to slide 19. Click on the little play button and you will be able to watch this video if I've linked it correctly. If you're not, just put it in the chat box and I'll figure out how to stream it. Yay!
One of these glasses is safe to drink. The other contains a toxic heavy metal that can cause long-term brain damage. Can you tell which is which? Lead in water is odorless and invisible. And in the tragic case of Flint, Michigan, here in the United States, poor planning and bad plumbing resulted in high lead levels in the tap water in people's homes. It was discovered far too late. We need to find ways to get clean, safe drinking water to everyone on Earth. A few minutes ago, we ran this lead test on these water samples. This blue line right here, that indicates that this water is loaded with lead. But according to this test, this water is okay to drink.
All right, it looks like you'll need to copy and paste the link into a new window or click on the little play button. I'm still working on embedding my own videos that are not linked to YouTube, so I'll try and get that fixed up there, but thanks for being my guinea pigs as I explored that. In this picture, this is really what we need to see here. He has two glasses of water. One of them came from the pipes at Flint, Michigan, and it is filled with invisible lead. And the yellowish one has no lead in it. And he takes a moment and he drinks some of the yellow one. And so that's what we needed to get from that video. And that's going to relate directly to our task. And if you come to the task bookmark slide, well, let's see. Connection to literacy, I played this at the beginning and you can watch this at another time, but there's a connection to a book called One Plastic Bag about how a girl uses trash of plastic bags to crochet purses and then sell them in her community. And it's a true story and it connects to this environmental task here. All right, our rich task bookmark begins on slide 22. And the rationale for why we do it is on slide 23. These are the math teaching practices established by NCTM in their Principles to Action book, and I hope to showcase every single one of these here today. Slide 24 is a problem-solving oath. I encourage you to read, and if you decide today that you're willing to make this oath and be a problem solver, go ahead and type your name in the chat box. Look at all these great problem solvers we have today. Alrighty, if you all will head on down to slide 25. If you needed the link, I just posted it again. This is the problem, and it comes out of a mathematics teacher educator journal. And it says here that Walmart, Coca-Cola, Nestle, and PepsiCo said that they will donate bottles of water for school children in Flint, Michigan to help with the city's public health crisis over lead-contaminated water. On January 26, 2016, the company said that they're planning to collectively donate water to meet the daily needs of over 10,000 school children for the balance of the calendar year. To do so, the companies will send 176 truckloads of bottled water, up to 6.5 million bottles, to Flint. How do we know how much water is enough to meet the daily needs of Flint school children until December 31st, 2016? And is the company's plan a good one? You'll have 20 minutes to work on this problem. There are some selected virtual manipulatives on slide 26 to get you started, but you're always welcome to use any virtual manipulatives or even Google manipulatives that you want. There's lots of ways of solving this. You can always add more slides if you need more space. I encourage you to work together, and as I put you in breakout rooms, just be ready to turn on your microphones as soon as you're in those breakout rooms and say hello to your team. Alrighty, our breakout rooms will start in 3, 2, 1, now.
Okay.
So it looks like we are group 4, correct?
How can you tell that? Where does it?
I'm
Oh,
group-
I see group
Hi
1.
group, just checking in with you. You are group 1.
Okay, perfect. Thank you.
Hi there group, just a heads up, you are group 2.
Thank you. Slide. What slide are we supposed
Hi
to
folks,
go to?
just a heads up, you are
29.
group 3.
Thank you.
So we're on slide 29.
29. Okay. And we're supposed to figure out, let's see. What is it again? Oops.
I'm going back and reading it again.
Hi group, just a heads up that you are group number 4. So you're going to be working on slide 30.
Thank you.
I think it's like 30.
And the storm is really bad right now.
Where are you?
Fairfax, Virginia.
Virginia. I'm in Olympia, Washington. Long ways away.
Oh my goodness.
Hi folks,
I know.
just a heads up that you are group number 5. So you'll be starting on slide 31. It looks like you're already starting, which is great.
I also noticed it said until the end of December. Is there a starting date?
Oh, that's a great question, but you're not going to get the answer because we don't have that information, so you all can make an assumption and roll with it.
And also I was wondering, does it mean that enough water while they're at school, or are they going to be taking bottles of water home for their quote-unquote daily use? I had lots of more questions than I could find answers for.
Absolutely. So make some assumptions and roll with it.
Okay.
Assume that we are not including the summer.
I don't know what concept bottle. So a bottle could be, one of the average ones that you get that maybe has like 8 to 10 ounces in it, or it could be one of those little teeny ones that has like 4 or 5 ounces.
Is it? Yeah. How do we know how much water will be enough to meet the daily needs of Flint school children until December 31st?
Oh, okay. Because it says up on the top, for the balance of the calendar year. So I was thinking if they're talking about school children. But I think you're right, yeah.
So we have 340 days. Let's assume it's a leap year. That sounds reasonable. 340 times 10,000. That's 3,400,000. And if we said they need 2 each day, do you think 2's enough? That's 6,800,000. So they're 300,000 or 200,000 short? No.
Okay, just 1 second.
What are you guys thinking?
So do we want to start, oh good, you started typing the assumptions. Perfect. So 5 days, 7 days, daily needs.
This side, because it's we're doing it 5 days. 5 times 500, no, 5 times 52. But then that's on the whole entire year because it's the 26th of, let's see, pull up an old calendar.
Well, it's, I mean, January 26th, 2000, the end of January to the end of December.
About 26 days. Subtract 25 days, that's about 340 days. So 650 divided by 340 gives us the number of bottles per day if you're looking at 7 days a week.
That's 1.9.
And how many ounces per bottle? Right? I mean, so there are so many variables that it's hard to really, I would say that we can't really assess whether this is a good plan or not because we don't have enough information. That's what I would say.
Well, and also too, like the age and size of the child is going to differ. Because
Sure.
like 2 bottles of water for maybe a 5-year-old, I don't even know if that's even sufficient, but that's going to be different than like a 14-year-old.
Sure, sure. But I guess we could say 2 bottles, it doesn't, well, I have other questions.
That math, like we have 6.5 million bottles, it says, and we have 10,000 children. So how many water bottles would that mean each child would have? And then we could just see, is that enough that would last? How many days?
And
that's
then
a good idea.
maybe we can take a look to see the quantity of the bottle so that if we know that, yeah,
The chart that was put up earlier that represents the number 10, was that 10 cups or 10 what?
10 cups.
Cups.
It's
Oh,
10 cups.
cups. Oh, okay.
I'll add that
Cups.
table.
So how
Yeah.
many cups are in a bottle of water?
Right.
2. I think about 2. If you do an
That's
average
16
bottle.
ounces.
so that's a pint?
You see, I've never used it before, so
Yeah.
you use it quite often?
I do. I've been using it a lot with students. Sometimes I have them go and play with something and come back. Other times we do screenshots, which is what I did. I just, on my computer, I have Snagit to do a quick screenshot, and I pasted in that picture to show the model of 1 million to help me visualize just how much that was, because it's a lot of bottles.
Hi, group. I love the way you have a visual and the table next to it because, yeah, 1 million for me is really hard to think of. My brain it seems to have some trouble wrapping my head around that idea.
That was exactly my problem, too, because 1 million is such a large number, and trying to match that up with 10,000 kids, and 10,000 is also a large number for my brain.
You know, I was going back to see the manipulatives, and I passed another group slide, and we were actually differentiating the ages of kids and how much water they would need. I thought that was kind of interesting.
I'm
How
just
many
looking.
Yeah, how many days did we say we were thinking of in a year? Like we were,
I think we use traditional 365.
but they're, okay.
Are they
Or-
only doing, you're saying are they only doing it when they're in school?
Yeah,
Right.
that's what, right.
180 days.
Okay, so I think we should.
But it does say for the balance of the calendar year.
Okay, the calendar year.
So,
Okay.
that may tie into a question that you'd want to know is if you're talking about a calendar year, are you actually talking over the summer when they typically would not be here? So that would still be an unknown. So you
Yeah,
need a range of data.
Are we also talking 7 days a week or 5 days a week?
Right.
And so I think you're going to end up basically with some kind of range as opposed to exact.
Okay, so if we're just assuming we're providing water every day, for the somebody bolded calendar year. Or was that always bolded and I didn't notice?
No, it just got bolded.
No, that's good. I was like, so to me that, so I guess in my head I'm thinking, I always think school calendar year, but that could, you're right, we don't know. So those are good questions. Okay, let me put that here.
So the other thing we could do once we know, like we know there's things that we'd have to clarify,
Sure.
we could pick one strategy and solve it that way.
I think that's good. I think we went, like we talked about if they were getting one every day, because assuming they need water and looking at how we're providing food and water for students now, and we're going to continue to do that over the summer, even though school's not in session, makes me feel like if we're being realistic, they need water all the time, not just when they're in school. So I think that makes sense.
So I'm just going to start listing those out, and if you guys have any more ideas, please feel free to jump in.
So for the sake of testing, should we say it's drinking water only?
Yeah, I think so. I think that's a fair assumption.
Yeah, I think that's good. Oh wow, 2 liters a day for 10-year-olds. So we maybe need to assume the size of the bottle too.
Yeah,
Oh, yeah.
I just realized that.
So I just did a quick search, and it says there's 750 milliliters in a bottle.
So maybe 3 bottles? 2 to 3 bottles would be close.
Okay.
What do we think?
3 bottles per child?
Per day?
So if saying 10 or below, then we could say an average of 2.
so I missed that a little bit. Did you say maybe an average of 2 bottles a day? Is that what you said, or 3?
Well, if we say 10 or below, like say like from age 2 to 10, we could probably say an average of 2.
I see.
But obviously, like, you know, like one of the questions, and I don't really know which quadrant to put this in, how do they select the 10,000 school children?
Yeah.
Okay, how are you going to do this? Ooh, group 6. All right, so we are going to look at okay, the big question here is, what does this table show us? They ID'd, they used it, now use it here. How does this connect with tables? All right, let's bring them back together.
Wait.
Bye.
Hello, everyone, and welcome back to the main room. Can you believe you've already been working on that problem for 20 whole minutes? I'm going to go ahead and mute your microphones just so we don't all talk on top of each other. And as some of you all are reconnecting, if you would just double check your mics that they are muted just to protect your privacy. We don't want you to think you were muted and then hear your background. Alrighty. So if you all would head down to slide 36, I want to be very explicit about what I'm doing during this time. I am modeling the 5 practices for orchestrating productive math discussions by Smith and Stein. I have already anticipated many, many ways that you all might solve this problem in a face-to-face setting, in an online setting, using a variety of manipulatives and even misconceptions. I spent this time popping in and out of rooms, looking at your slide, trying to get actual student work that relates to each other and relates to the math topic here. I've selected only 4 groups to review the work. That's not to say that everyone didn't have a contribution, but this is how I'm very purposeful in making sure that I have time to meet my math objective, and over time, all of my students would have a chance to present. I've already sequenced them, and I made a connections map showing the order and the questions that I want to ask in it. So I invite you all down to slide 37. And this group decided to start off with a visualization in order to start thinking about students in a table. Again, we're on slide 37, and if group 8 can talk to us, move that little red arrow along as you're talking to point us in the right direction, and tell us how you visualize this.
So my first question was to try to think about how big a million was, because it's such a large number, it's hard to visualize. I was even having trouble visualizing the 10,000 students. So that's why you can see with the red arrow here, I played with the place value discs and made a model to show how many 10,000s there would be in a million. And I was thinking about the 10,000 as an important number because that was the number of students. So I thought if we could figure out how many 10,000s there were, that would help us know how many bottles there were for each student. So then after doing that, we made the table where you could see the 10,000 would be 1 bottle per student. And then just reasoning up here, you can see the 100,000, the same as the columns under the blue disc, or under the light blue disc, I should say. You can see the 10,000s. And then just kept reasoning up all the way to 6 million, and then reasoned back down from the 1 million to 500,000 to get that 50 bottles. And then the final row here is the total of the 6.5 million bottles for 650 10,000s, or 650 bottles per student. And that just seemed like a lot of plastic overall for not much water for 340 days.
Wonderful visual and explanation, group 8. I would love to hear from another group, somebody who maybe has just had an aha moment, or if you're still kind of thinking about this. The first row that's identified in yellow, if you are from a different group and you understand this row, can you turn on, go ahead, raise your hand, turn on your mic, and explain why group 8 began with this row? What does this mean? Chelsea, go ahead.
What I see is that there's 10,000 students, and so it's a definite at least 1 bottle per student. So at least in one day, that's how many bottles that we use. So that's how I see it.
Awesome. And just lost my train of thought there. That was a really good explanation, Chelsea. And then why did they decide to end their table in the orange row? What information did they use to decide to end their table here? Someone from a different group. Sheila, go ahead.
Sure, I just want to get back to the slide. Okay, so we knew that the companies were providing 6.5 million bottles of water, and we knew that there were 10,000 students, so therefore each student would get 650 bottles total for the whole time period, and that was important to know.
I'm going to put a new question, and thank you, Sheila, that was a great explanation, a new question right below it. And I encourage everyone to try this new question and type your answer in the chat box. If we increased the number of students to 20,000, what might that final column, that final row look like? And feel free to put that in the chat box and collaborate. If we increase to 20,000 students, how might that bottom row look? So what I'm doing here is just getting a quick pulse, a quick formative assessment on, do people, first of all, understand the table, and then can they reuse the table in a different context? So now that I'm feeling pretty good about that, we're going to take a peek at slide 38. And group, you have a lot going on here, a wonderful math, but I want to focus just on this little tiny section that the arrow is on. How did you figure out these three scenarios? Again, we're on slide 38, looking at just the yellow arrow. Group 5, how did you figure those three things out? Let's see, who is in group 5? Can you tell us how you figured out the enough, barely enough, and not enough?
I can explain. Hopefully my teammates would join me. We figured out the same way that the 650 bottles were for each student based on the numbers that are going to be provided. But then it was never mentioned the size of the bottle, so that rather than the quantity as a whole. So we estimated that that our teammate was able to get the information that roughly 10 cups of water would be necessary per child, so that if we know that 10 cups and then changing it to the pints and quarts and ounces, so that if we calculated that if the bottle size is the 2-liter bottles, roughly for 2-liter bottles, then it will be enough water. But then if the size decreases, then it will not be barely enough. And then if it's going to be one of those mini bottles, pint-sized bottles, then clearly that's not enough. So we wanted to give a different scenario based on the type, the size of the bottles that may be going to be provided.
It's really interesting how you all saw this, and especially when we start to look at these problems as an international problem, we get into the reasons that we might use the metric system and things like liters and moving them into versus cups. And so we've got some great conversions there. Slide 39. Let's come on down there. Group 6 did a really neat little table, and I think that this table relates to both of the previous conversations. Group 6, can you tell us why you have two sets of numbers in this table here?
Hi, Dr. Wills, it's Erin. We kind of, looked at it, a little bit differently. We looked at, okay, if a student gets 2 bottles a day, we were kind of under the assumption at first that they were those 16 ounce bottles that you would, see from Costco or that were pictured. But then we were thinking, okay, wait a minute, that's kind of low. We got that 3.2 million. So then we kind of wondered, okay, what if it was 4 bottles a day? But then we even considered, well, what if they are those tiny bottles that sometimes they give out in schools, those kind of snack size? If instead of getting 2 larger bottles, they got 4 larger bottles, we're kind of reasoning that way, if that makes sense.
And why did you choose to use 2 different colors?
I can't speak to that. Maybe someone else in my group can.
So I put it in 2 different colors because when we first did the calculation, we did 2 bottles per student per day, and we only used school days because we didn't know how they would get their water in the summer. And it only made it to 3.2 million bottles, and so we said, well, maybe they really would use 4 bottles a day and could take some home. So we doubled the number of bottles per day, and so we showed the 2 colors and the 2 assumptions.
So I'm curious, let's use a little hive mindset here. What might be another row that we could put in this table? If you think you have an idea of another row that should go here, write the 4 numbers that should be in there in the chat box, and we'll go ahead and add to this table. What's another important row?
The whole year? Oh, oops.
So Jan wants to change the days. Jan, go ahead. You're going to fill out the next row. You've got row number 3. Chelsea wants to change bottles. So Chelsea, you're going to fill out row number 4. Any other important rows that you all are thinking should be included here? Kristen, you've got row number 5. Whoops. Hold on. Let me just undo. There we go. Row below. There we go. Kristen, you've got row 5. If I go back to slide 38, and I think about there enough, barely enough, and not enough, I would like to personally see a row where it's going to show that there's not enough there, but I don't know what it would look like. If anyone has an idea, you can go ahead and fill out row 6. What would be a not enough row? And whoever did the orange one, let's talk about that. Why do you think that this is a row that should be represented here, and what does it tell us?
It was me, Chelsea. Not all students will need all that water if they get 4 16-ounce bottles of water. So maybe there'll still be some extra left over. And that's some students that, like the athletes that stay after, like after school stuff, they'll get extra water if they need it.
I like the way that you're thinking about other people here. Absolutely. So there's a little bit of surplus, and then we can use those. And then we've got this one here, this final row. Who went ahead and filled out what if everyone gets 5 bottles, and what did you discover?
So my group was talking about students needing 5 bottles a day for the full, starting February 1st to the end, so for 334 days. And if they did that, that's how many bottles they would need.
Wonderful. And then finally, we have one more representation I wanted to look at on slide 40. Specifically, the ratios that are going on in the bottom here. And this is how many students start to show their work in figuring out how many bottles are needed. But the discussion I want to ask you all is, how is slide 40 similar and different to slide 37? Go ahead and raise your hand. Tell us, how is that similar and different to slide 37? And I guess we could also do 39 because that's also the table strategy. Monica, what pattern do you see? Can you turn on your mic and tell us?
Well, let me see. I have to go back. Well, definitely see the pattern chart that they have on Group 8. And what I saw on 40 was another pattern because they were showing if you put that into you could put that stuff in the table if you wanted. That's just what I was seeing. That they have the 5 days, 4 bottles. Yeah, exactly. And that's what I compared it to and saw. Yeah, exactly what you're doing. That's what my eyes, and I saw, oh, they're doing a pattern, and that's what popped in my head.
Very cool. April, go ahead and add to that.
Okay, so looking at slide 37, it looks like both groups are answering a slightly different question. So group 8 started with 10,000 bottles, scaled up until they got the amount that was stated in that article, and kind of saw how many bottles would that be, and then evaluated, okay, what would that look like realistically, for the school year. And then in the other, sorry, I lost track. Which slide are we looking at? Oh, in slide 40, so they started with their assumption of what is enough, and then scaled up to see how many total bottles would be adequate to, I guess, nourish the children.
Neat. So they're answering a slightly different question, but I heard you say the same word in terms of strategy, scaling up. Inga, let's hear from you.
They're both using the idea of a ratio. So they're starting out with what do you need per day? And it's either per individual student or per all 10,000 students. And then they keep working from that idea of per day up to like per week, per month, per day, per year. But it keeps going back to that idea of the ratio of number of bottles needed per day. And then they're all using that same concept, that same ratio concept.
Absolutely.
And they are scaling up.
Indeed. And if you did a ratio scavenger hunt, that would be a fun little extension for homework that you could do with this problem, where they just search all the other slides and they're looking for ratios. You might even include a unit rate scavenger hunt as well to talk about the difference between them. All right.
Yeah, and it helps them to see that the ratio can be a comparison of two separate things, whereas like fractions, when you initially teach fractions, it's not. It's comparing to the one whole, and those parts are equal. And then the ratio is still fractional thinking, but it helps them make that shift.
Absolutely.
That you can be comparing two different measurements.
Indeed. And those were connected at the very beginning in our task when some of us used unit rates, some of us use other ratio type thinking. And that is exactly kind of what the lesson was about. But on slide 42, and actually below that, I invite you to tell us, what grade do you teach? And what is a little part of this activity that you could have focused your discussion on because it hits that grade level? Is it ratios, unit rate? Is it converting? What do you teach? And what's a very specific topic that you could address? All right, I'm already seeing connections as young as K2 in talking about how many all the way up through 8th grade with linear relationships and dimensional analysis. I hope that this is a problem that you all can use in your class, that you can simply copy over that infographic, copy over the problem, and now you have some manipulatives that might be useful in solving it. Again, the recording of this and all the templates will be uploaded within the next 24 hours to my website, so you'll be able to have access to those, along with blank slide decks and the completed slide deck. And I'm going to say after for anyone who would like to chat in the virtual parking lot about like, how did you do this? But I hope you all enjoyed our task today. I hope it gets you thinking about the environment and the mathematics that can be in this social justice situation. And happy MATHurdays. All right, let's see. How do students take notes when you're teaching online? I'm not sure how to answer that. I guess they can write in notebooks specifically, but a lot of the tasks that I do, I am trying to build their problem solving, and so they would then use any of the slides, like they could go back to them and use that for homework problems. So I've never required any kind of formal note taking because they can use the communal notes that were left on the Google Slides. Let me stick an arrow in and feel free to make a new slide. Here, let me just do that. I'll make an extra slide below just so that you can post more questions there. Will you continue MATHurdays through the summer? Absolutely. As long as there's people to come to it, I'll continue to do it. It helps me build my bank of rich tasks that I end up using in my work anyways. If you head to this link here for PD registration, you can sign up for other MATHurdays. And let's see. How do we train students to work on collaborating? There's a couple things that I do in order to purposefully encourage students to collaborate. A lot of those things are things I would have done in the classroom anyways, but they're a little different online. So for example, in the classroom, if I had all my students wanting to answer a problem, maybe I asked a problem and I saw 20 hands up in the air. That's a cue to me that lots of students want to answer it, and I need to provide a way for them to have voice. Similarly, if only 2 kids raise their hand, I'm thinking, boy, not everyone is ready to respond. They need some more think time. So in both of those situations, that's my formula to know that I need to do a pair share where they partner up, they talk it over, and then we'll take a couple for the whole group conversation. And when I do pair shares online, I simply move them into breakout rooms with one other person. And when you do that, students can't really hide. You start a norm saying in small groups, all mics are on, and then it's just them and their buddy. And so they're more likely to start to share in that small group. Then when we come back in the whole group, they've had time to think about it with another peer. And they could even share out a peer's idea and not their own to lower that risk factor in the whole group discussion. So that's kind of a quick, easy tip to get them collaborating. I have trouble with fractions in Google Slides. I wanted to do this problem using dimensional analysis factor conversions, but need a way to show all in one long. So there's a couple tricks for fractions in Google Slides. One of them, if you're teaching the students, maybe 7th grade and up, Equatio is a good add-on. It allows you to do a lot of math type, but here's my favorite. It's so low tech, it's not even funny. 1/2, I just typed it there. I'm going to highlight 1 and I'm going to underline it, and now it looks like 1/2 with fractions. So I just use the underline feature for the numerator, and it does the trick that I'm looking for. And it doesn't have to be too fancy. It uses what's already there. How old are students when you're letting them go into breakout rooms with partners? As young as kindergarten. Um, we talk about norms, routines, and structure about what you do when you are in breakout rooms, how you behave, how we address cyberbullying, how they can be a cyber hero, how to private message teachers, and how to be a digital citizen very early. And that's part of many school systems' mission statement to build digital citizens. So I teach that at the youngest grades. We did that one. How do you think about synchronous, asynchronous in a course? My expertise is in synchronous and synchronous only. There's a lot out there on Twitter about asynchronous. It's just not my area of expertise. So much like you would ask, how would you do this in social studies? I might have a couple tips, but I'm not a social studies teacher. So I encourage you to check out Twitter. You can look up hashtag asynchronous. You can also look up distance learning, online learning, and you'll get some tips with that. My middle school students found breakout rooms really awkward. Any advice? Well, middle school students are going to find everything awkward. They're my favorite kids in the whole wide world. I always consider myself a 7th grade math teacher because that's where I started at and that's where I always feel like I go to. But they're going to be awkward no matter what. So let's give them a couple things to kind of reduce the awkwardness. Some of those is starting out in a pair share where they're with somebody that they find comfort in. Now that might look different in the fall. Maybe you have the kids give you information like, I know somebody from last year and it is so-and-so. And so you purposely group them with someone that they're comfortable with, and maybe only start in pairs. Once they get kind of the hang of it, you can ask them questions like, when you come back in the whole group, what's something your partner said that you thought was cool? And so now they're using the microphone, which is a little bit of the awkwardness, but really what they're doing is they're talking about what their partner said, and that brings the risk factor down a little bit. Another thing is I don't stream video. Most of you have seen me in many sessions before and you don't see me live because that takes up bandwidth and it's awkward. I don't like to see my face on the computer screen and a lot of other people are in that similar situation. So you can just take that down and give them more access. How do you handle wrong answers? I love wrong answers. I frequently use them in my math talk, but I will also let the group know, hey folks, I saw that you got the answer 82, and I want you to continue to think about that answer because let's say the correct answer was 820, and I say, you know, it's off by a certain multiple. I want to use 82 in the whole class discussion, but I'll strip off your identification and I'll just have a blank slide with the 82 and ask everybody else why you think 82 might be an answer someone got to. So I give them a heads up. I strip the identification factors, and sometimes I'll get students say in the math talk, "Ooh, that was ours." And then we learn to do the following. So they get excited to kind of own up to the mistake as long as you build that culture in your class. What if some students need more time to understand the problem? Gosh, that happens all the time in a face-to-face class also. I do want to end my class by summarizing somehow, but I never want to stop the thinking. So if they need more time, I would hope that every single person today might be thinking about this problem more, and I would put the assumption out that everyone could use more time. So I'd say, go ahead, take this home. Talk to somebody else about it, whether it's a sibling, whether it's your parent, a neighbor. Talk to someone about the problem and get their input. And then come back to class the next day and showcase one of the strategies, either the table or the step-by-step, using that new person's information and be ready to share it. And so everyone gets an opportunity for more time and the problem can continue. Where do you find the resources to make your interactive slides, also pictures? Like I said, I've been doing this for about 6 years, so I have quite a collection. I've made those available on my website. If you want to click here, you'll be able to see under templates all the different ones that I've used. And I encourage you, if you make some and you want to share them with the community, several of those slides on there are from other people that have said, hey, put it up there because I think it'll be useful. Someone said, may I share this with the authors? Absolutely. I'm hoping to get this out to the authors. If you'd let me know who that is and you feel like connecting me with them, I would love to be able to be in that conversation also. I saw a slide template, but required students to draw cards. How do you set up cards to draw? I am working on this video right now. It is, so I started off, before I was a teacher, started out in computer science, and I was always kind of perplexed with the weird way that computers have random number generators. And really, they're not random number generators. They are some kind of programmed pattern that people put in to seem more random. So I've created a bunch of card decks that they're not random at all, but I tried to make them random. So I sat there and I rolled a real dice and got the numbers and then programmed the cards to come out in that order. I'm hoping to get a video out in detail about how to do this soon. I've got a deadline with a book chapter that I got to finish up first, but after that, I'll get that out. So stay tuned. Do you spend any time teaching students how to use the manipulatives? Exactly. Exactly the same way I would in a face-to-face class. So in a face-to-face class, I would typically start off by using two manipulatives and making sure students saw a variety of ways of using them. And then I would also make the problem such that students would really want another manipulative. So if I'm using fraction circles, I would also make a set model where they're now frustrated that the manipulative was just area and they really want set notation. And so then I'll say, okay, well, we'll add this third one. And so I give them reason to want to choose. And then each new task, I would always make sure there's a familiar manipulative, so I didn't need to reteach that, and maybe a new one. And that new one's really going to give students access who want to showcase different things and showcase their knowledge of technology. Let's see, there's some questions on the next slide. I'm going to move there. I love the collaborative environment with the breakout rooms and giving students space to own their work. Is there an ideal class size for this? What if there's only 2 to 3 students that attend a synchronous class? Well, as you saw that you can do it in groups of about 5. But here's my general guidelines. If I have only 2 to 3 students at all, we do things whole group. As soon as I have about 6 students, I break them up into 3 and 3. Any less than that, and I found that it gets a little clunky. And also if you have really large groups of, let's say, 7 or more, some kids can hide easily or can feel like their voice isn't heard. So I generally try to get 4 kids in a group. When I'm working with teachers like you all, I know some people might leave the session early or not be as involved because they have something else going on. So I might up the number because that would mean like 4 people are involved even though there's 6 people in the group. So those are some tips that I use. How long do you typically spend with students setting up classroom norms? The entire year. I kind of set them up and set up new ones as they become needed. We practice them every time. We read out the classroom rules. A new kiddo would read it each time. So it's not just my voice, or we might practice one routine each day. But I constantly am bringing up norms so that they know the importance of it. And if I feel like our class really has the hang of it, I don't quit that time. I still plan the 5 minutes in my lesson, and I might bring up a new manipulative. So there's always a 5 minutes of chatting about norms or practicing a norm in my online classes. Let's see. How do you manage the demands for multitasking for you, the teacher, so quickly in the virtual environments. So part of it is I've had a lot of practice. I've been doing this for a decade now, and I kind of have a bit of a routine where I'll listen in at the beginning to get an idea of where groups are and probe questions. But then I put myself in the main room in a totally quiet environment as I'm creating my connections map. So I don't have any auditory distractions. I'm clicking around the slides, identifying which ones I want, and drawing the arrows to make those connections. So I get a little bit of quiet time to myself, and that helps me kind of prepare everything. Some school systems are not going to allow students to go into breakout rooms for privacy reasons. Any thoughts? Yes, I definitely have some thoughts on this, and I share them. If you want to sign up for the classroom management and accountability session, we go into this in detail. These type of restrictions are usually made out of fear that students are going to be inappropriate. And those same restrictions were sometimes made in a classroom. If you think to teachers who only teach whole class, usually it's because of fear of the breakout rooms or the breakout spaces, and what are kids going to do in those spaces, and are they going to be inappropriate? Through proper norms, rules, and procedures, and practicing those routines, you can develop a classroom management culture where students know what to do if a problem happens, how to be safe, and how to hold themselves and others accountable. To me, that's a simple classroom management issue, and I'm working with a couple school systems to kind of reevaluate those restrictions so that students can have more access to pedagogy that they are owed. So there's my little soapbox on that one. I used 2 computers at the start. I had a student teacher. Do you want to turn on your microphone? I'm really not sure what that is addressing.
So this is Jana. I was just thinking about that question about how do you multitask?
Oh.
And you said it's experience. And so I've been at this for 3 months, and I was lucky enough to have a student teacher at the beginning who was also in an online learning environment. And so having that extra set of eyes really helped me. So I would delegate to her watching the chat while I kept track of what was happening on the slides. And we also have paraeducators, and they join us in our synchronous classes. So you don't have to do it alone if your system affords you extra people.
Absolutely. Yes. Thank you so much for that tip. I had the opportunity when I was in the classroom to only teach in classes with a co-teacher. I was in a school where they made sure that the special ed population was spread out amongst all the classes, and I always had a special ed co-teacher. So I kind of used the affordances of that co-teacher in the face-to-face class in every experience I had. I do the same thing online. Do you have a session on teaching calculation process, like solving long division? No, I don't typically go through any kind of teacher-led instruction because I can usually find all the strategies that I'm looking for in student work. So sometimes people ask me, do you have a document camera? Do you pre-record lessons? And part of my pedagogical philosophy is to let it be student-oriented. And so if I'm not getting the strategies I'm looking for, I go back to the drawing board of the task and I figure out what about the task would get students to start thinking in terms of division and what might bring in several algorithms. I'll even have my students find algorithms on, let's say, Khan Academy or YouTube, and they find it on their own because of the necessity of the rich task, and they'll start to learn it and then they'll share it with others. But again, that's student elicited, and it's not me doing teacher-directed instruction. Okay, I think I got to everything. If there's another question, feel free to let me know. Otherwise, happy MATHurdays.
Teresa, I had a question about the original article in the NCTM magazine. Is it possible, would I have access if I had a regular membership?
Yes, you should. So you would look into an NCTM. There's the link for publications, and you should get access to it. I've put the APA citation at the bottom so that you could, find it easily. And I just put it again there. It should be under publications, and I believe you do get access.
Okay, thank
Yeah.
you.
Oh, thanks, Laura. Thanks so much for the kind words, everyone. Happy Saturday and happy MATHurdays.